Ma'am, you're not audible.
Everybody can hear me. Everybody can hear me now. Please say yes, then I can proceed. Hello? Hello? Okay. Now I guess I'm audible. Okay. So here we have question number one. I'm just going to repeat the question number one because that time when I was not available audible. So now question number one is arrange the following molecules in in the order of that decreasing boiling point. So first of all, we should know the factors behind the boiling point. So why the same molecule? So here you can see in all the structure we have CH3, this CH3, right? In all three structures. The only difference is here that functional group. So why the different functional group will change the boiling point? So for understanding this concept, I will write here the structure of acid, which is this one. I'm writing a general example, right? Because these acid molecules have two oxygen atoms and this OH group also, right, here to it. So because of this OH, it will make a hydrogen bonding with different other molecules of acid. So because of the hydrogen bonding in molecule and the strong electrons between functional group, it will not easily get boiled. Means the boiling point will get raised because of the strong hydrogen bonding. So already we studied about the hydrogen. So the hydrogen bonding plays a very important role. In same example, here we have alcohol and here aldehyde, right? So the structure of alcohol also can see here. This is the structure of alcohol, and I can write in this form O H, right? Here, and here aldehyde will be like this, right? So in these two structures, in this where OH is there, so OH is found on hydrogen bonding with another OH. The best example is that water molecule. Water molecule formula is also known as H2O, water molecule formula, right? But the boiling point of water is 100. Correct? Boiling point of water is 100. And if we talk about the other molecular formula, like suppose we have diachloromethane, DCM, right? Otherwise, we can take another example on this one. Also, we have diethyl, which is readily available in organic labs. If you are doing PhD, you can see these following are available in organic labs and used for extraction and purification kind of thing. So this is the structure of single bond O and again chain. So this is the structure of diethyl, right? If you calculate the molecular weight for both the structures, what you get? Molecular weight of this diethyl ether will always be higher than this water molecule, right? But still, because the molecular weight is higher in this case, it is volatile compared to water. The boiling point of diethyl ether is around 34 approximately. 34. Right? The reason behind this one, this diethyl ether will be hydrogen bond, but still because there is no hydrogen bond. You can see there is no OH present in this structure, but in water we have OH, right? Here we have OH. So because of this OH, it will make a hydrogen bonding. Hydrogen bonding is other order molecule, like this, right? I can show the printing with the rocket line, like this. So because of this strong hydrogen bonding, the molecule please mute yourself. If you have any question regarding that, you can unmute it. So this is the hydrogen bonding. The first bonding is increased. So the same is because the alcohol layer of hydrogen bonding contact. That's why this will show the high bonding compared to the aldehyde. Okay. So the order of the boiling point, decreasing order of the boiling point will be like first, second, and third. This. Okay. So the correct answer is first, second, and third. All of them understood why? Because in aldehyde there is no that means there is no hydrogen bond. And because of that it will become more volatile. And alcohol has OH and it will be hydrogen bond. That's why it is a second number. Its boiling point is more than aldehyde. And talking about the acid, here you have OH also and one more oxygen atom is there, so electronegativity is more and nuclear weight is also higher compared to this alcohol. OH is also there and nuclear weight is higher. That's why it will show the more boiling point, highest boiling point. Okay. Now let's move to the second question. The question is identify the intermediate X and Y and product find the following reaction statement. Can you tell me the quickly which name of reaction is there? Is this one? This is a natural reaction. I hope everybody has studied this in your lower class. This is a name reaction known as Grignard reaction. I hope everybody is aware of this reaction. So in Grignard reaction, what happens? All of you know that the Grignard reagent acts on a carbonyl-carbon, electrophilic center of carbonyl-carbon, and it will make an intermediate. So here we have four options. We will solve the question first of all, and we will select the right answer here. So talking about the Grignard reaction mechanism, what will happen? Here we have CH3 and GR, methyl methylene bromide. It will attack on electrophilic center in carbon dioxide, which is carbon, right? This is electrophilic center. So it will attack on here. Okay. So when it will attack here, the oxygen will take oxygen will form a bond with NCBr along with CH3 and Mg. So in here, in this case, you can see first step what's happening. It's attacking on this carbon. Right? So what will be the X here? This is one. And this one is correct. Right? these two have the common intermediate, which will form in this case of dry reaction. Because here we have dry reaction, there is no source of proton. In dry reaction condition, proton is not there, that's why it will form this intermediate. All of you understood? This intermediate. Because here it is taking the proton, but in dry condition, dry condition, there is no proton source, that's why X will be this intermediate. Okay? Then when we are protonating the reaction, we have done the reaction with H3O plus, that is the water addition. So H plus source. It will give a H plus source to the reaction, right? When we are doing this one, so what will happen is an H plus will be taken by this oxygen atom. Okay? And this will knock off. So what will happen? It will become an acid. Acid. Okay? So this is the correct option. And in other option you can see here the formation of alcohol is taking place, which is not correct. We have done the mechanism in which we can see that the methyl is attacking on the electrophilic center of carbon dioxide, and which is forming the COO intermediate, COO and GBr. And in next step, a protonation is taking place followed by the removal of MgBr. So that's why this one is correct. This option is the correct. Okay. All of you listen, if you have any doubt in between the class, you can ask. Okay. So the next question is, what is the final product in the given reaction? So I hope all of you have already watched the lecture which is uploaded by Professor Harina Chaturvedi. So here this electrophilic substitution reaction will be easy for you. So what will happen in this case? We have the AgOH. Reagent 1 is AgOH and reagent 2 is the allyl bromide. Okay? This allyl bromide. So in first case, this AgOH will act as a base, right? So when it will act as a base, what will happen? Which proton is more acidic in this case? In this acid, which proton is more acidic? This OH, correct? So AgOH will extract the proton from this oxygen atom, OH, this H, because this is the most acidic one, and it will form an intermediate which will look like this one. This one. This is again listen. This is the intermediate, not the product. Okay. It will form an intermediate like this one by attacking on this OH minus will take a proton from here OH and H2O elimination will take place, followed by the formation of intermediate which will look like O minus Ag plus. Okay. After that, the first reagent, the second reagent was added is allyl bromide. So what will happen here now? This O minus will attack on this sp2 carbon, and this bond will shifted over here, followed by elimination of bromide. Okay? Is it clear to you? I will show here. This will attack on this carbon. And this Br2 will knock out. Okay? So it will become like H. I'm writing CH instead of phenyl. O. O. Also understood this one because this double bond is shifting here and this DR is knocking off. So that's why the structure will look like this one, the final product. So which one is the correct option? This is already ruled out because this is the intermediate, right? And talking about the first one, so this is not possible because there is no oxygen atom is here. Because we have taken the acid and this is not the option. Okay. Now talking about these two third and fourth option, you can see here because all of you know that this intermediate was formed and Ag was present with this O negative. So this O minus will act as a nucleophile, not this one. Okay. So that's why because this one is attacking on sp2 carbon of this allyl bromide. So that's why the correct option is this one. All of you can see these are the same structure, right? So the correct option is 3. Yeah, I have shown here mechanism, common mechanism, not exact one. So as I told you, AgOH, OH will attack on this hydrogen and it will take up this proton to make it O negative. Then O negative and Ag plus intermediate will form and it will further attack on allyl bromide to get the desired product. Okay. So I hope all of you are clear with this question also. Now the question number 4. The Williamson ether synthesis is one of the several ways to synthesize ether. What type of mechanism involved in this synthesis? So all of you have studied about this type of reaction SN1, SN2, E1 and E2. Right? So anybody can tell me quickly about SN1, SN2 reaction difference? Anyone? Tell me what is Williamson ether? As earlier I have already shared the ether structure. So if you have studied in the lower class, all of you know that Williamson's reaction is like this one. R Na plus here it is mentioned that bromide is used, right? I am writing general reaction. So this is a bromide. Okay. What happened in this reaction? This nucleophile attacks on this carbon and simultaneously this BR will knock out. So this is the reaction which has occurring in concerted manner. I will show here. R, O, N. This is a salt form, right? So this nucleophile O minus will attack here and it will get knocked out. So here the concerted bond formation will take place simultaneously bond breaking and bond making. So we can show both the bond with dotted line. So I hope all of you understood now which type of reaction is this. So the bond breaking, bond making which is happened simultaneously is called under the SN2 type of reaction. What happens in SN1 reaction? SN1 reaction goes via carbocation formation. So if we see the SN1 type of reaction, the first carbocation formation will take place and then attack of nucleophile will happen. So SN1 type of reaction gives both the retention and inversion of the product. But in SN2 type of reaction, always the inversion of molecule will take place. Why inversion? Because the bond making and bond breaking will happen simultaneously. Okay. So this is the difference between SN1 and SN2 reaction. So talking about the even and E2 elimination reaction, in this case, elimination will take place. So because in Williamson's ether synthesis, we can see there is no elimination is taking place because you can see the valency of carbon is hybridization of carbon is really same. It we get here the product O, then again O. So we can write R1, R2 if these two groups are different. Okay. So all of you can see here, this is a substitution reaction. Why substitution reaction? Bromide is this R1 O minus is substituted after knocking out the bromide out. Okay, so substitution reaction type of example is this one is, and because substitution nucleophilic reaction, unimolecular and bimolecular are there. So in SN1, the carbocation formation is taking place followed by the attack of nucleophile. And in SN2 reaction, the both bond breaking, bond making is happen simultaneously to give the inversion of molecule. So I hope all of you are clear with this answer also. So this is the SN2 type of reaction. Now let's move to the question number 5. So the question number 5 is an ether is more volatile than alcohol, having the same molecular formula. This is due to I have already discussed this question in earlier, right? All of you remember the question number 1? We have discussed this one. I have explained everything. The same concept. I have told you both have same molecular formula. The only difference is the functional group, aldehyde and alcohol. So same here in question number 5. The question is the same, and ether is more volatile than alcohol, having the same molecular formula. The difference is intermolecular hydrogen bonding present in what? In ether or alcohol? Anybody?
Excuse me, ma'am.
Yes.
Ma'am, screen is stuck on question number 2. We can't see the questions.
Okay. So you should tell me earlier. Okay,
We have told in messages.
okay, I'm not able to see the messages because when I started the PPT, you should unmute yourself and then tell me. Is it visible now?
Yes, ma'am.
I hope now this screen is visible. This screen is visible. Now question number 5.
Yes, ma'am, it is visible.
Okay. So now we were discussing about the so listen before moving forward. I have discussed the question till question number 4, and you people are saying screen was not visible. So this recording will be available on the YouTube also, and link will be shared on Google Sheet. So you can go to the link and can see the recording. Okay. So I will start from this question number 5. So the question number 5 is an ether is more volatile than an alcohol having the same molecular formula. This is due to you have 4 options. Bipolar character of ethers, alcohol having resonance structures, intermolecular hydrogen bonding in ethers, intermolecular hydrogen bonding in alcohols. So as we had discussed in question number 1 about the hydrogen bonding. So all of you know that the factor behind the boiling point is mainly a hydrogen bonding, right? So according to this one, slides is moving or not now? I hope the screen is moving now. So here, all of you know that then the option third and fourth could be the answer between these two, right? Because we have already discussed the intermolecular hydrogen bonding. Now the question is which molecule will show the hydrogen bonding. So if talking about the structure, alcohol have this structure OH, right? And ether will have this structure. So in ether, all of you can see here only O is OH group is not present here. Oxygen is there, but it is not attached to hydrogen, right? And in hydrogen bonding, hydrogen is essential for making the bond, right? So because in ether there is no hydrogen present with oxygen, that side will not show any hydrogen bonding. So in alcohol case, it will show hydrogen bonding. So the option number 4 is correct. This one is incorrect. Intermolecular hydrogen bonding in alcohols. Okay. We have already discussed the concept behind the boiling point. So this is the correct answer. I'm going to change the slide. All of you please let me know this. You can see the next slide or not. Okay. So all of you can see the question number 6. Everyone. Please type yes in message box. No. There is some technical error, I guess. every time I have to do the back and forth thing. Okay. So this is the question number 6. I hope now it will be more clear to you. Yes. Question number 6 is predicting the product of the following waste. Indicate can tell me the answer. Yes, all of you know that ethanol is there, right? So, what will happen first? You know the structure of ethanol? Okay. Ethanol. So, here, what will happen? Ethanol have lone pair of oxygen. It will attack on electrophilic center of this carbon. Okay. It will attack here. And what will happen? It will get moved this side and opening will take place. Okay. Ring opening. So if I will draw mechanism here, arrow pushing mechanism is very important to all of you. If you learn how to do arrow pushing, you can solve any mechanism in a correct way. Okay. So always electron rich species will show the arrow towards the electrophilic thing. So here you can see oxygen have lone pair of electron. It is nucleophile. So nucleophile will always attack on electrophile. You cannot show arrow like this. This is wrong on this carbon. This is wrong. Okay, the donation of electron will always happen from nucleophilic side. Okay. So just take care of this arrow pushing thing. So here, this is going to attack on this carbon. Like this. Okay. So the next step will be mute yourself. Oh, minus. Correct? Alpha alcohol's group CH2, CH3, right? Alpha understood this one? Because this group is attacking on this carbonyl carbon and the bond breaking takes place. and this OCH2CH3 group will attack here and will give a product like this one, ester. This is ester. Now this O minus will take up the proton from the reaction mixture, because in here, listen all of you, here in every reaction you have to neutralize the charge. Okay? If you have started with the neutral charge, you should end reaction with the neutral charge only. And because here we have this proton, it will be taken up by this O minus and it will become a product like OH, and here. Can anybody tell me which one is the correct answer? ET means ethyl. Instead of writing CH2, CH3, we can write ET also. So, in these four options, which one is the correct? Fourth one, right? Fourth one is the correct answer. Okay. So, here is the accepted answer, and the mechanism will go like this. Now, next question. This is a similar type of question, right? In previous case also the ring opening was taking place here, and in this section also it will the mechanism will be like the previous one only. So the question is what is the major product of the given pH? Can you solve this question? So in previous case, the ethanol was a nucleophile, right? This ethanol was acting as a nucleophile. In this case, this is a amine. Okay? This is the primary amine where nitrogen will act as a nucleophile. This will act as a nucleophile, correct? So again the same mechanism, the lone pair will attack on any carbonyl carbon because it has symmetry. In previous case also the symmetry was present, that's why I have written this way. You can click the molecule by 180 and you will get the same structure like this, right? So here also we can make attack on any of the carbon present here. So nucleophile will attack on the carbon and again the ring opening will take place. This way. Okay? So we will write the product. First I will write in this form only to make you understand easily. So everything will be like this only. Next. Yes. 3. Okay, positive charge. This is the intermediate which will form here. Okay. Now what will happen? This O minus will take a proton from nitrogen and it will become like ONH pH 3 OH. Okay. If we will write this structure in linear form, we can write this way. Linear zigzag form. Okay. Here we have two CH2, so we leave two CH2, then carbonyl. Which one is the correct answer? This is okay. I hope all of you understood the mechanism now. Next question, question number 8. The major product formed in the following reaction is. Now this is the type of reaction where the epoxide opening is taking place, right? And this is a decalin kind of system, decalin. Have you heard about the decalin? What is decalin? Two six-member ring. So there is a two different type of stereochemistry in decalin, cis and trans, right? So the different conformations. Why I can't say configuration? What is the difference between conformation and configuration? So in conformation, the attachment, there is no bond breaking, only uh, the way of looking the molecule will change, not the stereochemistry or the bond breaking or bond making will form. In configuration, bond breaking and bond making takes place, which comes under configuration. So here we have different conformations, not configuration. So I will write here the cis and trans decalin. So what happened in cis decalin? Six-member ring attached to another six-member ring, either on wedge bond or on dash bond. You can write both ways. Both are correct. Okay. This is cis decalin. Above a plane and one hydrogen will be on below the plane. Okay. So this is trans decalin because these two we are talking about in terms of these two hydrogens. If these two hydrogens are on same side, it will become cis decalin, and if both the hydrogens are opposing one another, that means it is a trans decalin. So we can write here in chair form. Okay, this is the chair form. So I have made a trans decalin here. Sorry for the confusion. So as we know that cis decalin have both the hydrogen on upside. So here all of you know that this is the axial, this is equatorial, again this is equatorial, this is. So in one case, when the axial bond is there, that means it is trans, right? And equatorial upside, you can see this equatorial bond is upside on this carbon, and axial bond is downside. And talking about this carbon one, the upside bond is axial and downside bond is equatorial. So if both the hydrogen is on upside, that means this is up and this is equatorial is up, right? So this is called the cis. We can call it cis, right? So the remaining bond which is left is downside bond, right? So either we can make it upside or downside. So I am just going to make it downside. This is proton. Okay. So here this is a cis-decalin type. And talking about the trans one, this is the trans one. Why trans one? Because both equatorial bond are forming a trans. Here both the proton are opposite to each other, right? According to this structure. Now talking about our question, here instead of H we have CH3. So I will write here CH3. Yes. Okay. Now we can see one CH2 is there between the epoxide and methyl group. So here it this one we will consider CH2 and we will make a epoxide one. So all of you can see here the methyl stereochemistry and epoxide stereochemistry is same here, right? And hydrogen is below the plane. So because CH3 is here upside, so we will make the epoxide on upside only. Okay. Okay. So all of you clear with this structure? Now our nucleophile will attack on this epoxide and it will open the epoxide. So we have here PHS minus as a nucleophile. Phenyl. Sorry, S minus. This is our nucleophile. So where it can attack, there are two possibilities. One, it can attack from this way, or it can attack on by this way, right? So because here one free diaxial interaction is taking place, which make the energy of the molecule have. So because of this one free diaxial interaction and hindrance, this route is not favorable. And here, because there is no one free diaxial interaction on or any other barrier, so this will prefer, nucleophile will prefer to attack from this below the plane side, and epoxide opening will take place like this. So if I will draw the structure here, it will become OH will become on axial side, right? And because the attack is taking place from below the plane, so on axial position, this SPH group will come. SPH. Correct? So if we will write in normal form, this is our CH3, right? The stereochemistry of CH3 will not get affected. Stereochemistry of CH3 will not get affected, and proton will also remain as it is. Now, all of you can see OH is have a same stereochemistry as CH3 has. So OH will come on this side, on this carbon, right? OH, and SPH is below the plane. Below the plane. Okay. All of you got this? How to solve this type of question? Which one is the correct option now? Tell me quickly. Option number 2. So whenever you have this type of question, just make sure you are drawing the correct chair conformation. If you are making a chair conformation, it will become easier to understand from where the attack will take place and what will be the stereochemistry at the end of the reaction. Okay? I hope all of you understood this question as well. And just try the same reaction with different try the same concept in different reaction condition. Like take here cis decalin and then do the same reaction. It will be helpful for your exam and your practice. Not talking about the next question. Question number 9. Predict the major product formed in the following reaction. Can anybody tell me? Here, epoxide formation is taking place, right? In previous question, we were doing the epoxide opening. Now, in this case, we are making the epoxide, right? So, when we are doing forming the epoxide, we are taking the per acids. Per acids means here the structure is given RCO3H. So, R group could be a different group would be possible for here. You can study about epoxide, so you will understood about this one per acids. Okay. So in this case, per acid is used for epoxidation, but which one will be the product? In question number 1, we have already discussed about the hydrogen bonding, right? Hydrogen bonding makes a molecule stable, and it will the stability will become higher, the volume will get more. Okay. So because of the stability, hydrogen bonding will play a very important role here. So because here we have OH and here epoxide formation is taking place, here we have oxygen, right? And here also we have here we have hydrogen and here we have oxygen. So hydrogen oxygen will form a hydrogen bonding. We have shown in case of water already, right? So here there are two possibilities of product. So what will be the major product? Our question is what will be the major product? This is the chat confirmation. So I'm just making OH on equatorial position. Okay. Here we have double bond. Okay. Now, when epoxide formation will take place, okay, like this. So when the epoxide formation is taking place, the hydrogen bonding will play an important role. Here, the hydrogen bonding is takes place. So because of the hydrogen bonding, the epoxide will prefer the same stereochemistry as hydrogen bond have. Okay, to make it easy for hydrogen bonding, the same side of stereochemistry will be preferred by the molecule. So, because in these two cases, option 1 and option 2, the same side stereochemistry is present in option 1. Here, it is easy to form the hydrogen bonding, and hydrogen bonding always stabilizes the molecule. So, because of stability, this answer will be the correct answer. Major product will be this beta epoxide. When do you have any question? I can't hear you. So here, beta epoxide will form as a major product because the stereochemistry of OH and epoxide is same. And it will form a hydrogen bonding which will stabilize the molecule, and the more the stability, the major will be the product. Okay. Turn off your camera. Okay. So the product is A1. Sorry, option A. Now the question number 10. The suitable reagent of the following conversion is. So there are different epoxide reagents, right? Different per acids. So which one will be the suitable for this type of reaction? Talking about the reagents here, MCPBA is used for electron-rich double bond. So because epoxide formation is taking place on olefin, so here all of you know that olefin can be a electron rich also, and it can be a electron deficient also. So when the double bond is electron rich, that time MCPBA will act as a great reagent for epoxide formation. And now the next reagent is H2O2, and here acetic acid. H2O2 and acetic acid is used for the olefin reaction, but it will give a product like, show here, this is olefin 2 OH and OH. It will not give you a epoxide. Epoxide opening will take place by acetic acid. Okay, so it will give this product. So this option is incorrect. Talking about the option 3, third butanol. Uh, this is also per acid, and this one is used for the epoxy reaction of double bond which is present in linear chain with halides, like this type of epoxidation. So here this is not the case, so also this option is not correct. And now MCPBA, in between MCPBA and H2O2, the difference is that MCPBA is used for electron rich one. I already told you electron rich double bond, and H2O2 will attack on, will be helpful for electron deficient. So in this question, the double bond is electron rich or deficient? Anybody can tell me? Which effect is there? So you can see here there is no electron donating group. If here double bond OCH2 group was there, that time this olefin will become a electron rich, because this will show the plus M effect, mesomeric effect, lone pair will be shared here, and this double bond will be electron rich. But this is not the case here. This is the electrophilic center, and this is the electron deficient olefin, because of this electron withdrawing group, right? Because of that strong electron withdrawing group, this olefin is become electron deficient. So for electron deficient, H2O2 is the correct reagent. H2O2 in NaOH. So the correct option is option number 4. Sorry for this one. Ignore this one. The correct answer is H2O2 and NaOH. Okay. I hope all of you understood this question as well. Now the last question of this section is question number 11. A chemist carried out a Fischer esterification using methanol that was isotopically labeled with 18O, indicated with an asterisk, this star mark. Okay? Identify the product after the reaction. So this type of reaction we have already done previously. You can see here, in this case also, when ethanol was attacking here on this carbon center, and it was become the reaction was taking place. The other example also we have done, in this case, right? This type of nucleophilic attack is taking place in this reaction. So same in question number 11 also. Here we have methanol. Methanol oxygen will act as a nucleophile, O minus, right? It will act as a nucleophile. What will happen? It will attack on this carbon. We have discussed that nucleophile will always attack on electrophilic center. So because this carbon is electrophilic, if we will talk about the charge distribution, this oxygen have delta minus and this carbon have delta positive. So because the electrophilic center is this carbon, so methanol will attack on the carbon followed by elimination of this OH. So in first step, I will write by step, then it will be easy for you. This is single bond. Now this is O, CH, and this is O, H, and minus. Right? And now protonation will take place. Okay. EH, because here you can see protonation is there. So we will do the protonation. O H 2 plus this will become OCH3 minus. And this negative charge will this come back here and water molecule will be knocked to give the product EH OCH3. Can you see here the oxygen which is present in this acid, this oxygen is knocked out with as a water molecule, right? And the oxygen of methanol which attack on this carbonyl center is retained as it is in the molecule, right? So if you see the four options, here this oxygen is formed acid. So all of you know that this oxygen is knocked out with the in the form of water molecule. So this is not the correct one. So talking about the second option, you can see here O star, which is the part of the methanol, is present in the product. That means it is attacking here, right? Same here. Same. I will make a star on this one. So this is the correct option. Here, this is also not correct because the lone pair of oxygen will push here and this oxygen is not the one which will form the carbonyl carbon. Okay. This is also not correct. So the correct option is option number 2. All of you understood? I hope this question are clear to you. I will just make a quick revision of today's class. So we have discussed the different types of question. Here we have done the 11 questions. The question number 1 was the arrange. Question number 1 was arrange the following molecule in order of their decreasing volume. I have discussed the different effect of hydrogen bonding, and I have given a different example also like ether, diethyl ether, and a water molecule. Because of hydrogen bonding, the boiling point is increases. So in this case, you can see the alcohol had the hydrogen bonding, but aldehyde, in case of these three molecules, alcohol and acid both are showing the hydrogen bonding. But aldehyde don't have hydrogen bonding. That's why the aldehyde will have the highest boiling point. And if talking about the order of the decreasing boiling point, the order will be like this one. Boiling point, sorry for the confusion. Boiling point of aldehyde will be the lowest one because of the lack of hydrogen bond. And now in between the first and second molecule, first molecule will have the higher boiling point because of the higher molecular weight, and hydrogen bonding is a common factor between the first and second, but the molecular weight is higher for the first one. That's why it will show the higher boiling point. Okay. Then we have discussed the question number 2. Where we have discussed the Grignard reaction. In Grignard reaction, we have done the reaction on the carbon of carbon dioxide, and we have seen that the this CH3 minus act as a nucleophile and attack on the carbon to form a intermediate. So here you can see the intermediate will form because it is a dry ether condition. We have observed that the OMGBr formation was the intermediate. Then protonation will take place to form the corresponding acid. So we have discussed this reaction mechanism as well, and the correct option was option A. Then we have moved to the question number 3, and we have done the predict the we have done the product formation in this type of reaction. So here we have observed that AgOH acts as a nucleophile, and it will act as a base, and it will take up the proton, and it will give an intermediate like this one. So we observe here the option number 2 was incorrect, because this is the structure of intermediate, not the product. Then followed by the attack of this O minus on the allyl bromide to give the final product as this one. So the correct option was option number 3 in this case. Then we have discussed the question number 4, where we were talking about the relations ether synthesis, and we have observed that ether synthesis goes through the mechanism involved SN2 reaction mechanism, because the bond breaking and bond linking was happening simultaneously. So we have concluded that the correct answer for this question is SN2. Then we have done the question number 5, where we had the question, and ether is more volatile than the alcohol having the same molecular formula. So this question was the same as we have discussed in question number 1. So the hydrogen bonding was playing the important role. So the correct option for this question was intermolecular hydrogen bonding in alcohols. We have done the question with example. Then question number 6, we have done the reaction mechanism, and the product formulation we had done here. So this is the same type of reaction, electrophilic substitution reaction. So here ethanol oxygen was attacking on the carbonyl center, electrophilic carbonyl center here, and it was forming an intermediate like this. Then after the formation of intermediate, the protonation will take place to give the desired product. So the option number 4 was the correct one. Then we have done the question number 7, again similar type of question, and we have done the mechanism. Again, nucleophile was attacking on the carbonyl center, followed by opening of the ring to give the corresponding product. The option number 3 was the correct option. Then we have done the question number 8, where we have discussed about the gallon system, and we have done the cis-gallon, trans-gallon, and mode of attack. So here we have discussed about one diaxial reaction as well, and the more favorable side for the reaction. So we have observed that the nucleophile was coming from below the plane and on this carbon atom. So from charge confirmation, we have concluded that the option number 2 is the correct option. Then question number 9, we have discussed the epoxide formulation, where we have talking about the hydrogen bond. So because of the hydrogen bonding, the beta epoxide, which is the option number 1, is the correct option for this type of reaction. Beta epoxide will stabilize the molecule by making the hydrogen bonding. Now, next question was what is the suitable reagent for the following conversion. So we have discussed the different type of reagents here, and we have discussed that MCPDA is a suitable reagent for the electron distable. Right? Talking about the SO2 and NOH was the reagent suitable for the electron deficient bond. So here, because we have the electron deficient olefin bond here, so that's why the option number 4 was the correct option. Now the question number 11 was the question based on the isotopically tested of reaction mechanism. So here we have discussed about the Fischer acidification, where this O star will attack on carbon of this acid. And here we observe that this oxygen is coming from the methanol, not from the oxygen OH group. Acid OH group. So the correct option was the second. Okay. So I hope till here all of you are understood. If any question, any doubt regarding these questions are there, you can ask me now. Everybody are clear? Any question is there? What is 322? You are texting in messages. Any question is there? I hope all of you are clear with this one. If you want the class on NMR spectroscopy also, which was also taught by Professor Halina Chakrapani, so you can ask me in this class, then I will cover the topic in the next session. Do you want class on NMR spectroscopy and the question based on NMR spectroscopy? Please type yes or no in text box. Okay. So in next class, I'll be discussing some NMR type of problems and the basics behind the NMR spectroscopy. Okay. So I hope in this class, all of you are clear with these questions and practice more this type of question for your exam. Okay. Thank you so much for attending the class. Okay. And in next class, we will be discussing about the NMR also, and we will learn about the new topic also. Okay. So in the next class, you can ask me a question, whichever doubt you have on NMR, you can ask me in next class. Okay. Thank you so much for attending the class. Now you can leave the class. Thank you.